Hello out there, welcome to this tutorial on trigonometric ratios. So we start with problem 1. Find the value of x in each of the equations below. And we should know that the value of x lies between 0 degrees and 90 degrees. So we have A, B, and C. So we start with A. Sin x is equal to cos 50 degrees. So we are going to consider important identities that will be relevant for this solution. The first one is cos x is equal to sine 90 degrees minus x. Sin x is equal to cos 90 degrees minus x. So we now look at whichever way we want to go. Since we have sine x is equal to cos 90 degrees minus x, that is the particular one we are going to make use of. For the original equation, you have sine x is equal to cos 50 degrees. Then the identity we are using, sine x is equal to cos 90 degrees minus x, which means cos 50 degrees is equal to cos 90 degrees minus x. That's what it implies here. Since sine x is equal to this, sine x is equal to this, which means this is equal to this. That's what we just did. From here, since this is cos and this is cos, I don't want to say they cancel out, but you can now see that this cos 50 degrees is equal to 90 degrees minus x. We then bring them together and solve for x. We're taking this x to the left hand side, it becomes x equal to 90 minus 50 degrees. This is minus x. On getting to this left hand side, it becomes positive. This is 90, still maintaining the right hand side. Taking this 50 degrees to the right hand side, it becomes minus 50 degrees. So we have x equal to 40 degrees. That is to say that sine 40 and cos 50 have the same value. So that's all for A. We then go to B. For B, I have cos 2x is equal to sine 36 degrees. We go back to our identity. This is the one in cos, but here now we have 2x, which means our 2x will be coming here too. That's the only thing that will be changing. Cos 2x will be sine 90 degrees minus 2x. So we have it as cos 2x equal to sine 90 degrees minus 2x. If it is x squared now, it will still be 90 minus x squared. So that is it. Then we then look at, since this is cos 2x, this is cos 2x, this sine 36 degrees is equal to sine 90 degrees minus 2x. And also from here, this is sine, this is sine. It means 36 degrees is equal to 90 degrees minus 2x. We bring them together again and solve. This minus 2x coming to the left hand side, it becomes 2x equal to 90 degrees. This 36 coming to the right hand side, it becomes minus 36 degrees, giving 2x is equal to 54 degrees. 90 degrees minus 36 degrees is 54 degrees. Dividing both sides by 2, x will be equal to 27 degrees. If you divide 54 by 2, you have 27 degrees. And that's all for B. We then go to C. For C, I have sine 3x is equal to cos 7x. Just like we just did in B, it means we are going to have sine 3x is equal to cos 90 degrees minus 3x. So we have it as sine 3x is equal to cos 90 degrees minus 3x. This is equal to the right hand side, this is this, which means cos 7x is equal to cos 90 degrees minus 3x. and this is cos, this is cos. It's telling us that 7x is equal to 90 degrees minus 3x. Bringing them together, 7x is equal to 90 degrees minus 3x. We take this minus 3x to the left hand side, it becomes 7x plus 3x is equal to 90 degrees. It's going to give us 10x is equal to 90 degrees. Dividing both sides by 10, x is equal to 9 degrees. So we are done with 1C, and this is the end of solution to problem 1. We then go to problem 2. For problem 2, find the value of theta if 0 degree less than theta less than 90 degrees. And we have the questions to be solved. Starting from A, but we still remember our important identities. So we start with A. For A, we have sine theta is equal to cos theta minus 30 degrees. We look at this identity again. We are going to make use of the second one, which is sine theta equal to cos 90 degrees minus theta. Since the left hand sides are equal, so the right hand sides are also equal. Cos theta minus 30 degrees is equal to cos 90 degrees minus theta. Since they are both cosine, so theta minus 30 degrees is going to be equal to 90 degrees minus theta. So equating them and solve. Take this minus theta to the left hand side, we have theta plus theta. This theta to be added to this one coming here. This is going to be 90 plus 30 degrees. Theta plus theta gives 2 theta. 90 plus 30 degrees gives 120 degrees. Dividing both sides by 2, theta is equal to 60 degrees. And that's all for 2A. We then go to 2B. For 2B, cos 2 theta minus sine 7 theta is equal to 0. We are going to rearrange. Take this minus sine 7 theta to the right hand side. We have cos 2 theta equals sine 7 theta. If you take this sine 7 theta to the right hand side, it becomes plus. So again, we check the first identity here. This is cos 2 theta. If I multiply the theta by 2, it means I'm going to multiply this theta 2 by 2. So we now have cos 2 theta is equal to sine 90 degrees minus 2 theta. The left hand side are equal, so the right hand side will be equated, so that we have sine 7 theta is equal to sine 90 degrees minus 2 theta. Since they are both sine, so we are going to have 7 theta to be equal to 90 degrees minus 2 theta. Take minus 2 theta to the left hand side. I have 7 theta plus 2 theta is equal to 90 degrees. Remember, this is minus 2 theta. Coming to the left hand side, it becomes plus. So this is 9 theta is equal to 90 degrees. Dividing both sides by 9, we have theta to be 10 degrees. And that's all for problem 2B. We then go to 2C. For 2C, we have sine theta plus 30 degrees is equal to cos 2 theta minus 39 degrees. We make use of the second identity here. Since this is sine, theta plus 30 degrees, which means 30 degrees is added to theta. So we're going to do the same thing. 30 degrees will be added to this theta before the subtraction. So we are going to present it as sine theta plus 30 degrees is equal to cos 90 degrees minus theta plus 30 degrees. We place the theta plus 30 degrees inside the bracket, because you are at the same time going to subtract theta and 30 degrees. So since the left hand sides are equal, the right hand side are also going to be equal. So we have cos 2 theta minus 39 is equal to cos 90 degrees minus theta plus 30 degrees. So since both of them are cosine, so 2 theta minus 39 degrees is going to be 90 degrees minus theta plus 30 degrees. So we have 2 theta minus 39 degrees is equal to 90 degrees minus theta minus 30. I have expanded this bracket. We then bring this minus theta to the left hand side. 2 theta plus theta is equal to 90 degrees minus 30 degrees. This minus 39 degrees coming to the right hand side, it becomes plus 39 degrees. This is 3 theta equal to 99. 90 degrees minus 30 degrees is 60 degrees. 60 degrees plus 39 gives 99 degrees. Dividing both sides by 3, we have theta to be equal to 33 degrees. And that's all for problem 2C, and this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.